We are doing 3-5 today, which is parallel lines and triangles. And some of this is going to look really familiar to you, I believe, because you've probably done it before at some point in your life.
But I thought you were going to look at our homework.
Oh, I'll check it later.
I was going to mention that, but I knew, I was like, okay, some people didn't do the homework.
Someone didn't do it, so I won't say anything.
That was such a small class that I totally forgot.
I'll check it later. Okay, so parallel lines and triangles. There is what's called the parallel postulate, which pretty much says if you have a line and you have a point here, there's only going to be one line that goes through that. Daniel, put it away. Okay, so I can only get one line through that point that will be parallel to the line that's given, right? The only line I can draw that's parallel, that one didn't work out very parallel, but pretend. There's only one line possible, okay? It's called the parallel postulate. I will never ask you to name it for me, so don't worry about the name of it. Just know there is one line. This one you'll use a lot. This one's called the triangle angle sum theorem. And this is the one that I think you probably already know. You maybe just didn't know it was called the triangle angle sum theorem. But think about what it's saying, the triangle angle sum. So in a triangle, how many angles do you have? 3. What is their sum? 180, right? So this one, the triangle angle sum theorem, just says the sum of the measures of the angles of a triangle is 180. So if this is A, B, and C, basically what we're saying is the measure of angle A plus the measure of angle B plus the measure of angle C will always be 180. Okay, so a triangle always has to add up to 180 degrees, no matter what. So if we think of that as, well, I'm gonna show you a triangle and show you why that is. So give me a sec here. Okay, so knowing that a triangle always adds up to 180, here's what you're going to have to do with that. First example, if I give you this triangle, oh, that's not straight at all. A little better. So this is A, B, C, and D. Let's say we know angle A is 59 degrees. Angle B is 43 degrees. That's not really angle B, I guess. This one's 49. And then this is X and Y and Z. Okay, so we have 3 missing angles in this setup. Cameron, you with me back there?
Yeah.
Are you on your iPad right now?
Yeah.
Put it away. So if this is my setup, I can solve for X, Y, and Z. Does anyone see how I could solve for one of them?
You do 59 plus 43 and then get that to 1 minus,
Not minus X.
What?
So if we want to start,
Oh, the 59 plus 43 plus X equals 180.
right. So you take the 3 angles and you add them together and set it equal to 180. So that means 59 plus 43 plus X, right? That's the 3 angles of this triangle. So if I just look at that triangle right now, those 3 angles are 59, 43, and X. If I add those together, because they make a triangle, they should add up to 180. Okay? So then you simplify it. 59 and 43, that is 102 plus X equals 180. Did I do that right? Yeah. So take away the 102. This is gone.
Is that a Z?
This is a Z. Wear your glasses.
But like, why is
Keep forgetting to email your mother.
Gloss through it, though?
Oh, I always write my Z's like that so they don't look like twos.
All my 7s
Yeah, I do that too. Yeah. Although I didn't right there, but I often do. So that's 78 degrees, right? You're just taking away the two angles that you know from 180, okay? And if I were you on these, I would draw the picture, because when you draw it, you can then write in that missing measure. So X was 78, and that usually helps you see how you would find another one. How would you find Y right now?
Put the X, substitute the X.
You're going to use X.
Now substitute the 78 in the equation.
Subs. There you go. It makes a straight line, right? So X and Y together should add up to 180. So you would say 78 plus Y is 180. So take away the 78. And you get Y is 102. Which is interesting because we saw 102 over here. I'm going to show you a little shortcut in a little bit. On our next problem, I'll show you
All four of those make a straight line.
a shortcut. It's the angles. This is your vertex right here, right? The two angles that form that straight line are the X and the Y, right? So this angle is 180 degrees.
Okay, not the two in the end. 59 and Z.
Not 59 and Z, no. Okay? Okay, so then that's X and Y. Z, you have some options now. How many triangles do you see in this picture?
3.
There's 3 actually, right? There's the green triangle on the left, this triangle.
There's only 2
Oh.
triangles.
No, because there's the triangle on the left, the triangle on the right, and then there's the whole big one. This triangle. Right? So you have options. I would say the easiest one to work with would be BDC, the one on the right. So to find Z, we would do 49 plus 102 plus Z equals 180. God bless you. So 151 plus Z is 180. So we're just going to take away the 151.
29.
And Z is 29. Okay. Questions on those? Okay, so that's using triangle angle sum. There's another theorem that deals with the exterior angles, and I'm going to show you that one right now. But I'm going to draw you a picture first, and then we'll talk about what it says exactly. Okay, so if this is my setup, and this is angle 1, and angle 2, and angle 3. Which one of those angles do you think is an exterior angle? The one that's not inside the triangle. So angle 1, okay, this angle here is called an exterior angle. But what makes it an exterior angle is not just the fact that it's outside the triangle. It has to be that you have a side of the triangle. So here's the side of the triangle. And then it has to be the extension of another side. So in other words, if I were to extend these sides, this X is not an exterior angle because that's the extension of two sides. You have to use a side. Okay, so we could call this angle 4. Angle 4 would be an exterior, or angle 5 would be an exterior. But this one is not an exterior. Okay, it has to be that one side gets extended and the other side is the side of the triangle. Okay. Then we have 2 and 3, which are called remote interior angles. What do you think of when you think of, like, if I'm going to a remote island, what do you think of? Away, far away. So remote interior angles are the two angles inside a triangle that are farthest away from the exterior angle. So my exterior angle was 1, so we can't use this angle here as a remote interior because it's right next to it, right? The remote interiors are the ones that are across from it, farther away from it. Okay? Faith, quit tattooing your arm. and pay attention. So that's what this one says. This is the triangle exterior angle. Theorem. Okay, and what it says is the sum of the two remote interiors will equal the exterior. So I'm just going to redraw the picture. It's the same picture, but with less of my scribbles all over it, just so you can see what I'm talking about. Here's angle 1, here's angle 2, here's angle 3. The way this one works is the measure of angle 1 will equal the measure of angle 2 plus the measure of angle 3. So if you add the two remote interiors, it will equal the exterior. Here's why. If I were to add them all up, 2, 3, and 4 add up to 180. 1 and 4 add up to 180. So 1 has to be the same value as 2 and 3 together, right? So all you need to make sure of is that the exterior, angle 1, equals the sum of the two interiors, 2 and 3, two remote interiors, okay? So angle 1 equals angle 2 plus angle 3. Questions on that? Okay, let's do one. Let's do 2 actually, and then we're done. So this is example 2. And we have this picture where this is 80 degrees, this is 18 degrees, and we want to know the measure of angle 1. Okay, so if we're thinking exteriors and interiors, which one's our exterior angle? Angle 1. Okay, our remote interiors are 80 and 18. So what do we do with 80 and 18? What do you do with the remote interiors? Add, subtract, multiply. You're going to add them, right? So it's going to be the measure of angle 1 equals 80 plus 18. So the measure of angle 1 would be 98 degrees. Okay? Now, this is a shortcut. Does anyone see a different way you could find it? Subtract from 180, and then what are you getting? Which angle? You're getting the interior angle when you do it that way, right? But that's the way you could do it. We know a triangle adds up to 180. So this triangle is 180. So if I call this x, 80 and 18 and x will equal 180. So if you don't remember the shortcut, you could always do this. Take away 98 here, and you would get x equals 82. So if this is 82, then 82 plus what has to equal 180 because that forms a straight line. Okay, so you do have options, but regardless, you're going to get that the measure of that angle is 98. Just don't forget that if you forget the one, you can do the other. Okay? Okay, now this one's a little bit different. What do you do with this one? What? Exterior is the one on the left. This is 59. We want the measure of angle 2. Okay, so now they give you the exterior, and you have to solve for the interior.
So this is different?
It's different just because of the information you're given, than where you're given it, but it's the same setup. It's still the exterior equals the sum of the two interiors. So what equals what in this problem? What's your exterior? 124. So that's still the one that's going to stand alone. Equals what? Yeah, 59 plus the measure of angle 2. Okay, so you're just subtracting instead on this one. Thank you. So you get the measure of angle 2 equals 124 minus 59 is 65. So the measure of angle 2 would be 65 degrees. But again, there's another way, right? We could have looked at this setup up top, 124, and what adds up to 180 right here, because that's a straight line. So that would be 56. And now you have a triangle with 56, 59, and what add up to 180. So there is always a second way you could do it. It's just this way is quicker. Okay?
Okay.
Questions? That is it.